Pro presenters. So welcome, Sharon.
Thank you very much, and I'd like to thank everyone at ASHRAE for inviting me to be a speaker today, as well as you're making the time to be here. Hopefully, it will be at least informational. You'll at least get one or two good points out of it, if not more. I always feel when I go to a training session, if I can even get a couple nuggets out of it, it was worth my time. So I hope to over-deliver on that. But again, my name is Sharon Dinges. I have 30 plus years in the commercial HVAC industry, from mechanical equipment, systems design, love system stuff, building automation, energy savings, performance contracts, but I'll save those details momentarily. And so today, from the flyer, what you saw is my goal. I love to train, I love to teach, I love to mentor. I've been very fortunate to have really good mentors along the way in my career. And so today what I'd like to be able to do is increase your understanding of the buildings and the systems within, quite likely taking a very different perspective than what you might be accustomed to in ASHRAE, as well as unlocking the potential of those facilities, the assets within the facilities, the data and the information that's just sitting there as these golden nuggets, right, that are there, and are we making the most of that information? And then identifying ways to improve energy efficiency, sustainability, indoor environmental quality, operating costs. Those are just a few of the benefits. And then some basic ways to take action by identifying budget and capital-friendly opportunities. So what you're going to find is we already know ASHRAE. We have ASHRAE guidelines, we have ASHRAE standards, we have ASHRAE and local codes and standards, I'll say, codes and guidelines. This is going to be stepping into a slightly different perspective. Do we have any owners or operators in here today? Okay, well, when you're working with them and they're looking for something to do, especially right now, when we're looking at the increasing cost of energy, everything is pretty expensive, right? How can we empower those customers? So when I did customer visits, and I'm going to drop down here so you can feel for who I am. That's part of my background, but again, 20 plus years with Train, and one of my favorite things to do is when they came to the White Bear, Minnesota facility, is to talk with these building owners. And a lot of them, they're like, come on in, take care of everything for me. But others were like, look, we have a very small budget. Right now, we want to do what we can do by ourselves. In fact, some of them would even have the dads come in, back in the day of just dads only being the hands-on, right? And they changed it up, all the T12s for T8s. That was something that they empowered themselves to do. So some of what we'll be looking at would be what can be done outside of the ASHRAE guidelines without ignoring them. So just understand, absolutely, ASHRAE and the local codes and guidelines are absolutely necessary, right? Those regulations, but this is a slightly different flavor on everything. But I had the opportunity, part was mechanical. I started off in the Fort Wayne, Indiana commercial sales office, wanted to get closer to the equipment, moved down to the Macon, Georgia factory for Train, where I did technical support as a tech support engineer, did some program management, good old SWAS, commercial self-contains. Anyone familiar with commercial self-contains? Some old stuff, but you might run into it in existing buildings, right, rather than new construction, perhaps. And then I fell in love with controls. My background is a degree as a double E, and I got very involved with ASHRAE SSPC 135, which is the BACnet standard, and began with them in 2005, developing standards, involved with updating Train's controls, which meant that I needed to understand everyone else's out there. And what I loved about that is I keep saying Train, right? But the environment, it's co-opetition, right? We need to cooperate with people who may be our competitors on any given day, but at the same time, we're all raising the water in that harbor, so all the ships rise. So enough of that. And so why do I want to talk to you about this today and why now? So my passion, as I stepped away, I'm semi-retired, is, again, very good mentors in my career. One of my favorite things to do when I led my engineering team, when I was doing ad hoc work with even colleagues, right? Director of engineering. And I love teaching and training and mentoring, and not just one way, but the two-way street. And so I thought, let's take a little time today and put on that hat. So pressures, do any of these resonate with the folks in the room here? Yeah, Yeah, right, regulatory requirements, energy efficiency, lean. How many people are stretched doing 2, 3, 4 jobs, or how many jobs just kind of fall by the wayside? You just don't have the people who can pay attention to things the way you'd like them to. Existing buildings, how do you upgrade those, make those more energy efficient as economically as makes sense? Dealing with the legacy equipment and systems in there, the key performance indicators, key performance metrics. This next one, when I think of data centers, right, that is a market that is just exploding across the country and within Arizona as well. But how do we deal with things about acoustics and water and energy and that heat island effect that can take place? And I'm not going to dive into that. That's an area of interest for me to learn more about, right, as we go forward. But these are some of the pressures that I suspect each of you or many of you are facing on a daily basis. And then new players in the market space, right? We have people that are really good at software, right? They're software companies, they can lay in, they can go over, but are they doing the right things with the equipment in the building? And so when I first joined back in '93, I got involved in the industry, and one of the things that came about was, how do you do energy management? And Don, I know you would remember this, is when there was the energy crunch in the 70s, and the utilities interacted with the buildings. A lot of times it's like, let's shut down those chillers, let's shut down those big pumps, those fans, whatever it is. And we experience premature failures. And so we need to be wise about AI is great, both from capabilities as well as being able to view in. And the new entrants are very helpful, right? But how do we make sure they're doing the right things with these very valuable, very precious assets in our buildings? And again, going back to, I had great mentors. I want to be able to turn around and give a hand up to the next generation. We have boomers, Gen Jones, and Gen X. Many of them are stepping back or have retired or moved on to other locations. Might be a little more on the horizontal side, some of us. But the other is they may have moved into different positions, right? So to me, that's part of what this industry is about. How do we train that next generation and learn from the next generation, right? It is a two-way street.
Who are the Gen Jones?
That is, for those of us who don't feel like we're boomers or Gen X, it's 56 or 54 to 65, like, it's that. Because we were kind of that sandwich, yeah.
Got it.
Yeah, I learned about that about a month ago. I'm like, yeah, that's a Jones, right? Yeah. And opportunities, right? How do you differentiate yourself, right? Whether it's in your career progression or with your customers, again, there's a lot of competition in the market, right? How do you stand out from that competition? And within your organization, growing and strengthening your team, speed to completion, right? How can you move more quickly? Because I'm assuming there is a lot of pressure that once you get on the job site, how quickly can you get off the job site with a minimal punch list and the key turnover and all that stuff, right? And then at the very end, when we take a look at this, is what is some of the low-hanging fruit that is out there? So let's take a look at this. We're going to look at, within a building, you've got the facility infrastructure and the systems, right? You have the building that's put up there, but what do you have? You have electrical, you have plumbing, you have fire, you have access control, safety and security, CCTV, you have your IP network that goes in there. The information and the data, what do you have available from these systems that are in your building? And are they talking together with the facility integration? Are the systems talking? Are the systems working as they ought to work? What data is available from one system to another? Might it be beneficial to share, and not to share that data just because you can, but because it makes sense, right? Because we are dealing with some legacy systems here. There are manual forms of integration. How many people are comfortable with controls and systems integration types of topics? Just to get a feel. Okay, that's great, great. And then taking action by identifying and prioritizing, right? So again, what is your why? Right? They're not occupying the building. Your customers are not occupying the building to have HVAC equipment and to have lights and to have the fire and the safety and security. What are they in there for?
Comfort.
Comfort. And what kind of comfort? What if I'm in K through 12? What kind of comfort might accompany K through 12 schools?
Yeah, temperature, IAQ, acoustics.
acoustics, lighting, they're in the business of education, right, but healthy and safety, right, so let's take a look at this. Right, so K through 12 schools, we have manufacturing, right, you need to have your uptime, you need to make sure that you have your PMs, your preventive maintenance, while also having reactive on-demand maintenance, so you might have a computerized maintenance management system in there that's integrated. You've got up in the upper right-hand corner, universities. Universities pretty much have everything that's shown in all the other facilities on there, right? You've got kitchens, you've got lodging, you have classrooms, you have office space, natatoriums, which have their own challenges, right? Hospitals, healthcare, surgical suite turnover rates, right? One of the early development, I'm just going to say probably in the early 2000s, was how do you control the humidity so you can make quick changes between temperature, because this procedure and this surgical suite may need these conditions temperature-wise, right, for optimal outcome. But these might need slightly different, or this surgeon prefers that temperature, and this one prefers this one. So you don't want to be dealing with that latent load, right? You want to control the humidity, not such an issue as much here as it would be in other parts of the country, but it's still an issue, while still responding to those temperature needs. And was it nosocomial infections, right? Hospital-acquired infections. So whatever you do, you want to make sure that your patient can leave healthier than when they came in. They might have recovery time, but we certainly don't want them to become ill because they've been in our hospital, right? And then HIPAA, right? We need to have security, so you need to pay attention to who has access to what, right? Within the system, office space data centers, again, that's one that's rapidly growing, and that's the one that I want to wrap my brain around, because there's some great things that come with it and some not so great things that come with it if we're not careful. And where I'm going to focus today is on office space, because it is present in most of these locations, right? Even if you take a look at some of the data centers, they're promoting their data center. By the way, if you're leasing this rack space, and I've got my security in my rack space, I've got the cameras, only you have access to that. By the way, if you're leasing space from us, you have access to these meeting rooms, right? So they also have offices that need to be handled. All right, so let's take a step first, looking at the life cycle of a typical building. So you've got your new construction phase, ongoing operations, future upgrades and modifications, and end of life. How many have done retrofits or dealt with retrofits of existing buildings? How smooth are they? Oh, they didn't update the as-bills to indicate that pillar was there or that beam was there, or that they changed out that equipment. So I'm trying to do a takeoff and a quote and get out there. This is how much time I have allocated. Oopsie. Right? So there are a lot of it depends moments, right? So how do you minimize those? And then end of life, right? We all were familiar with LEED when it came in. If you were in the industry when it came out, but we're still working with LEED today. How do you make sure that you're siting properly, you don't have a lot of drift and loss of the soil, that you are doing the right things, you're sourcing in a sustainable way without getting crazy about it, right? Let's not do greenwashing. That's the other thing that it was tempting when LEED came out. A lot of people, I think there was a phrase about, did your green building turn brown? And so that's why a lot of the standards were not just for new construction, but ongoing operations was another LEED certification you could get. Because, great, I got it. Now let's forget about it. Let's let the set points get out of control. You can have drift. Someone put something in override. And so now that outside air damper is always open, so I'm needing to overcool or dehumidify my space, or my set points have drifted, someone overrode the gymnasium and it's still in manual mode, right? There are a lot of these things in existing buildings that we need to deal with. And then so the systems in the buildings, obviously, I'm going to guess most, if not everyone knows building load calculations. You might be doing simulations versus the manual on the paper that we were talking about. Systems and equipment, size and selection. So how do you prevent oversizing, right, where you might have some short cycling of systems. And you're not paying for more, but keeping in mind that it does need to be adaptable as you go forward, right? So what do I need today, but what do I need down the road? for my building. So you have as designed, right? This is what we think it looks like. Then we have as installed. So as you go along, maybe in your specification, when you have these are the products that are approved, this is how we think we're going to install it, we might have realized we need to make a pivot, right? We put in a change order, and so what comes out of there becomes as installed. But then as commissioned, right? Commissioning agents to make sure that you're getting what is required. How many have to deal with commissioning agents or are commissioning agents? Just a few? Okay, all right. So that is an area that if we do it right, it's benefiting our customer, right? We want to make sure that they get what they need. And then recommission, retrofits, and remodels all factor into that. And one of my favorite things is the building is alive. It's very dynamic, completely dynamic. And so again, that building, the mission of that building does shift over time. Even if you're the same facility, hopefully your organization is growing and expanding. And one of my favorite examples of that is back in the early 2000s, I had the opportunity to be working on an energy savings performance contract. I was the controls and system applications liaison with the team. And we were at a military base, an Air Force base in the Southeast. And at one point, racquetball was really big. You know, I played my racquetball and things like that. And if anyone's played racquetball or seen a racquetball court, you might have, what, 3 people, 4 people on the court, maybe a few more, right? You're playing doubles or you're playing cutthroat. Yes, you have sweaty bodies, but you're in a box, right? And there are 3, 4 of you. But they wanted to retrofit it to be a spinning studio. How many people do they pack into a spinning studio? Yeah, many, many, 20, 30, 50, whatever that number is, right? They pack in a lot of sweaty bodies. And they couldn't figure out, gee, we have mold issues. We can't keep these guys comfortable, right? It was horrible. I'm like, great idea. And so that was part of the performance contract, was doing the energy modeling. And I won't take credit for the energy modeling, even though I've done energy modeling. That was not my role on that team. But what was the right equipment? What was the right air exchange in that facility? It's something just that simple. Unintended consequences, or when they're blocking off the outdoor air intake, right? It's too cool, it's too stinky. Well, what happens? You have your fresh air intake. What happens when you block that off, especially in an older building? What can happen? Stuffy. So I'm sucking in, right? What if that's my only route for that air to come in, makeup air or something like that? Not a DOAS unit, right? But bringing in that fresh air. How about infiltration? Around the door, around the windows, unconditioned air paths versus the intended path of fresh air where we're managing that. So simple things like that happen all the time, right? And then again, operating parameters may change over time, right? We're changing set points, we're changing time of day schedules, whatever that happens to be, volumes of outdoor air. Maybe I have a greater occupancy. So I need to change my occupancy rate if that's one of the ways that I'm controlling my ventilation. And again, operational issues and inefficiencies, right? If I've got a VAV box up there, is the damper working? And reheat is not a big one, right? It's frowned upon in many applications, but what happens if I'm doing simultaneous heating and cooling and I don't know that I am? Yeah, exactly, right? These things happen. I've got a broken valve, I've got a broken actuator, I've got a bound actuator. These are very real situations that you run into. All right, so let's take a look at that office space. And I have pulled myself back because I wanted to really put a lot in here. I realized I had 45 minutes with you. So I did not try to over communicate here. So here's an example of what might be a mission in an office space, right? So a productive office environment. I want it to be, I don't want to hear the guy next to me crunching on his chips or tapping his pen, right? Maybe I want some white noise in there, right? So a little bit of sound is good. How do I acoustically handle that? But attractive to occupants, right? If it's a commercial leased space and the dollar per square foot, maybe, especially coming back from COVID, right? We had a lot of people working from home. And I can tell you on the north end of Phoenix with one of the groups that I had as a client is they were working with their property management firm, and the management firm was between, do we raise the rates and bring in better amenities so we can bring people back, or do we just get out of this business altogether? So some are opting, let's make it a premium space. And so you can differentiate yourself that way. And then again, tenant fit out is common. So whereas in a building like this, we might be able to have very fixed locations for everything, even down to our zone sensors and our CO2 sensors, or however we're sensing things, being aware of where you may need to have flexibility in how various tenants, current and future, may be using that space, so you don't have to do a massive remodel and retrofit at that time. Some of the special considerations, just a few examples, and there are many, many, right? Building certifications, so going back to LEED, some of the other ASHRAE building codes, things like that. Market differentiator, be able to say, I'm in a LEED Platinum building, right? That speaks for my brand. My customers, when they're taking a look at my online presence, might say, this company, these are their sustainability goals, right? And ESG done the right way, right? Not just to get stamped ESG, but to truly lean into what is beneficial and meaningful, right? From environmental, social governance, is those might make a difference. And by saying we have these operations, here's what we do with our energy footprint, we track it, etc. If you're leasing space from there, that can be helpful as well, right? You can point to that. Multiple tenants in a single building, so going down to number 2 under systems and equipment. If you have multiple tenants in your building, how are you going to bill for electricity usage, or maybe it's chilled water usage, or whatever that is, what for the service that's there? Because this company may work, I won't say 24/7, but maybe they work 6 days, 7 days a week. So they may be having a greater demand on the energy consumption, whereas these guys over here might only be 5 days a week. And so what happens? Am I splitting it up? Am I dividing it by square footage? Do they have a higher plug load, right, where they're generating more heat because of what they have in that space? How do you do it equitably? And a lot of the energy management systems today can help you get there. Right? But you need to think. You don't need to. It's beneficial to think about these things ahead of time. So I don't want to say that. So again, the subset, we already talked about that. So a lot of the equipment, you have HVAC, lighting, access, and security. So only the people who belong in your space are in your space. Or if there's after hours, how do you accommodate for someone coming in after hours to work? Because it's not uncommon, right? I've got a project coming due. I'm going to be working Saturday and Sunday. So I'm going to, if I'm not able to work from home, or if my resources are in that office space, how do I handle that? So again, just a few of the opportunities and challenges that are there with office space. Is this okay so far, guys?
Mm-hmm.
Okay, just want to make sure I'm tracking. All right.
And Sharon, you can use this little clicker if you like.
Thank you. Now it's going to be exciting. All right, so some of the challenges and opportunities, right? So challenges, you have islands of information. Opportunities is how can you integrate the information and the interactions between the systems, and thinking about that as you walk in. And a lot of your companies, no doubt, we used to call them cookbooks, we used to call them playbooks, manuals, whatever that is. Here's how things might work together, which makes it a lot easier. But what happens when you go into an existing building? Again, you may need to start from scratch and figure out what they already have. Oh, by the way, under this pile of manuals is an old dusty computer from who knows how long ago. And do we even have the service and setup tool? If you're in building automation, right, there were tools often that you needed to use, and that was a whole different hurdle that needed to go over, is open standard systems, and we'll talk about that momentarily, versus I have service tools. So when you're specifying a job and you're working with something, are you getting the service tool if you need a service tool? A lot of them have their own setup pages and other ways of techniques with our current technology. But again, when you go into legacy systems and legacy buildings, you may be dealing with some old stuff. So when you're walking that facility, when you're talking with your clients, and you see they have an automation system, what is that controlling? Is it still controlling those items? Do we have any pneumatics still here? Okay, that's what I thought, right? Yeah, so pneumatics, right? They're really good at moving big dampers. Really, really good, right? So you need the PE, you know, pressure to electric, anyhow. What do they have in there? And so does someone have one of those old service tools? Does someone know how to work on that system so you can get to that information? And as you go in there, if you're doing a retrofit, obviously I'm talking a retrofit here, is one of the strategies that we always used was, or always sought to use, was if I'm putting in new equipment, maybe I'm gonna lay a new conduit. Now we've got wireless and all that, so it's different, but again, you still have legacy buildings and systems, right? So paying attention to what's in there. And so, let's see, what else do we go? Coordination and control of this. Visibility, it's not at all uncommon for those silos of information to exist. And take a look at this momentarily when it comes to the integration side of things. So you can have data integration, right, where I'm actually sharing information with everything. And then you might have point-to-point wiring, and just like if you're wiring up a little thermostat, right? You can bring the wires to it, or I'm wiring in a stop button or stop switch, right? That might be a hardwire to the e-stop controller for that piece of equipment, right? And where was I going with this one? Single seat of operation. You may run into, I can get the information this far, but maybe I need to use I'll keep using the word workstation, but it's your laptop, it's your smartphone, it's what your web browser, right? Where I can look at all the systems and create a page that I don't need to jump around. You can do graphics that bring this information together. So in that single seat, I have visibility to things. They may not be talking completely, but at least I know where to go. That's one of the challenges as well. How do I get to that outdoor air temperature sensor? When I look at outdoor air temperature for this chilled water, hot water air handler, where is that? Is that directly wired to the piece of equipment, or is it communicating from another part of the facility? And is it located in the right location, right? Or am I getting afternoon sun on that sensor, which is now requiring me to overcool, right? Those are some of the things that come on. And this is one. You need to see it to be able to manage it, to be able to control it. And so that's where, again, going back to your energy management systems or other windows into your systems, how do you get there? So again, centralized control, monitoring, and management. The graphical display, I think that's come, you know, we're nowhere near where we were when energy management systems began really gaining traction. And we're still, how many buildings would you guys estimate we have here in Phoenix that actually use energy management systems or building automation systems? How many of you guys encountered?
Oh, let's call it 20%.
Yeah, I thought 30 would be generous. Yeah. It's pretty low. And that's why part of my focus, I'm hitting the automation system hard. You need an EMS to qualify for some of this. Otherwise, you're operating blind. You need to be able to see it. Scheduling occupancy, right? It's great when your time of day schedule remains as it needs to be, but what happens when you need to have exceptions? Maybe we have a weather incident nowhere near what we had in the north, right, where we have snow, well, Flagstaff, snow days. We would get 4 feet of snow in a 24-hour period, right? So we had snow days there. Payson would be probably very similar to that. But then settings for temperatures and humidity and fresh air and CO2 set points and all of that. A lot of the graphics, they have the thermal graphics, right, where they can change the colors on the graphic to indicate deviation from set points. So if you're looking at it visually, but that's great. How do you know that you deviate from set point if you're using thermal graphics? you need to have someone who's actually looking at that user interface. Versus, I'm able to set up some alarms, some trend logs, some historical data that will send me a message, or even better yet, automated fault detection and diagnostics and resolution of the situation of saying, oh, this is out of control. I'm going to send an alarm over here, I'm going to log it in the system, but then I'm just assuming we have some advanced technologies or we have some very smart software and application engineers thinking about this, or the person who's sitting on the OSHA-approved 5-gallon bucket mechanical, writing the code for it, saying, well, if it gets beyond this, let's reset it, right? Or let's do whatever it needs to be done. So things to think about. And that's system virtualization and then the systems integration. So 3 types of information, at least in my little brain, I think about it, is you've got the human, you've got the occupant, right? The top are what are some of the things that are their needs, right? I won't read everything to you, but then from the occupant level, what do they need, right? What might they want to be able to do? I want to play with the set point in my room. Do we really want them to play with the set point? Or do we want to put a dummy thermostat, or do we want to clamp it?
Small.
Right there.
Small variation of set point.
Yes.
Adjustability, that's it.
Yes.
They can slide it up and down as much as they want.
Mhm.
Maybe it's plus or minus 2 degrees. That's what I used to do. It was very fast.
Absolutely. So they have a little bit of control
Right.
versus using it as an on-off switch. Yeah. Alright. And so then here's some of the data types, some of the information that is often available and could be shared, could be touched, right? And where do you get a lot of that information from? Thermostats. What are the thermostats? Let's switch from thermostat to zone sensor. And what is that connected to? What does the zone sensor connect to?
Analog input on a controller.
That's right. You've got a unit-mounted controller. You've got an AI if we're looking at temperatures, if we're looking at an on-off control, DI, DO, things like that, right? If we're
Temperature sensor would be analog.
Yes, they can be. Absolutely. Yep. Yeah, agreed. Fan start stop. We'll go fan start stop. My brain was going for which one would be a good digital. Yeah, agreed. So these, you have what's on the wall in the room, and depending on what that zone sensor looks like, you have more or less ability to touch these things, to see these things. But then you've got the unit controller that then interacts with the piece of equipment, right? It controls the equipment, it gets feedback from the equipment, but that unit controller, if it talks, if it's integrated into an automation system, it then can be controlled and put together as a system within that automation system. And we'll take a look at what that looks like. I won't have enough time left over at the end to go there. And then lighting needs, right? Making sure that the lights come on where they belong, or tying in HVAC and lighting. I'll go into that momentarily, so I won't go too deep on this one. But then let's take a look at the systems and equipment. So you've got equipment operation, system level operation, facility level operation. And then here's an example. If you're looking at a VAV air system, and we'll look at that on our EMS graphic, is you've got an air handler, you might have some VAV boxes, maybe you've got an exhaust handler in there so you're not overpressurizing. Yes, you could have DX in there, but we're going to pretend it's chilled water system and the devices that are associated, pumps, valves, hot water system and components, right? And then taking a look at all that, those are just a few examples. Time of day scheduling, making sure that everything, if you're saying go occupied, it's not going to do you any good to bring the air handler occupied if your boiler, not your boiler, if your chiller and the pumps and valves don't know it's time to go occupied, right? You're not going to do much. And then at the building level, and again, I throw these terms around, I think we could put facility management control system as another term. Basically, what is it that's coordinating either that space or that facility or even at the campus level? Central control and operations, energy dashboards, and again, facility level control and visibility, and you typically have, whether it's a facility manager, a property manager, someone like that who actually has the help. And again, some of the coordination, and by the way, I'm doing fire and smoke control. right? You've got air handlers. Are you approved? Are your sequences approved to do, if you're on a multi-story, like atrium type of fire and smoke management? Crazy there. Pressurizing, or I'm purging, or I'm preventing fresh air from coming in, whatever is appropriate, depending on where that fire or that smoke situation might be. So again, going into those strategies with facilities. All right, so let's look at a few pretty pictures. So on here, as soon as this is up. There we go. So on here, I've got my cooling tower, I've got my chilled water, hot water, air handler over here. Down here, I've got good old boilers. I've got my VAV boxes, I have my ductwork. This is not rocket science to anyone in this room. I need to get water from my mechanical room down here, maybe my chiller plant, my boiler plant, up to the roof. What do I need? Pumps, valves, proper sizing, and things like that, right? So this is what we're going to have in the back of our mind as we talk about these things. All right, so how do we get these things to work together? And again, this will be a review and probably very remedial for a handful of you, and hopefully it will be some, didn't think about that, moments for the rest. So with each of these, right, we have equipment controllers on everything because we need a way in. And you've got a chiller or chillers, cooling tower, towers, boilers, pumps, things like that. That can be put into a chiller plant control application, right? And you've heard of chiller plant control, near optimal control. I think all the EMS vendors have one flavor or another that they know works. And it allows you to make sure that you're evening out the runtime on your chillers, if that's the way you want to do it. And you've got your older, less efficient chiller over here that, oh my God, if you really need that extra oomph, we'll do that. Some of the applications, maybe I'm doing ice storage, so I can build ice, I can burn ice, I can blend ice and chilled water depending on my load, right? Those are different things that can be controlled with this, as well as just centralized everything. On the air handler side, right, I've got my VAV air system. So I'm looking at when I've got a call for cooling, if I just have one VAV box that's calling for cooling, do I bring on the whole air handler if it's Saturday morning? I don't know. Is it the president's office? The CEO's office? Maybe. But that goes into the things to think about. When do I allow everything to come on and come occupied, right? Or what are the minimum number of boxes, because I can only turn down the fan on my air handlers so far, right, to stay within the proper operation of that fan curve. So how many boxes do I need open? And then, you know, here's our friend the exhaust, right? I need to have a way to relieve, and I'm not over or under pressurizing my building. So what does that look like? And so here we are, we've got an EMS, might be cloud, it might be on site, we need to have some sort of control. But then we have building controllers. Where are these applications going to reside, right? I've got the unit controllers that talk to building controllers that can then talk elsewhere. All right, so there's other building controllers. I'm showing just one, but if you're on a campus, you might have 50, 60 or more, right, depending. BACnet over IP typically is what you'll see, in that there are other ways to get there, but that's the predominant one, and having been on the BACnet committee, I love my BACnet. At the unit controller level, it's typically BACnet over MSTP, right? A whole twisted pair side. It might be Lawn Talk. Lawnmark International's Lawn Talk. Again, existing buildings, you're going to run into these. It might be Modbus RTU. In fact, that little exhaust fan, maybe I'm talking Modbus to it. Power meters, energy meters, right? So I'm doing sub-metering in this office building for my various tenants. That might actually talk Modbus RTU. And there are bridges, there are ways to translate between one protocol and the next. And if you're talking BACnet, you're talking device profiles, right? I've got a workstation, I've got a building controller, I've got an application-specific controller. I have an advanced application controller, so it's programmable, or it has more capability in there. And then I have my data sharing, going back to the AI, AO, DIDO, just because it has the temperature on the unit controller. Can I touch it? If I'm someone else's system, can I control that that temperature set point from another system, is it writable or is it only readable? So some of the things to think about when you're looking at systems. And again, as you go forward and work with your consulting and specifying engineers, or you're doing that if that's your role, making sure that you're able to communicate the way in which you and your customer in that facility need that to communicate. Right? If you're talking lawn talk, you've got your lawn mark functional profiles, which get into the interoperability as well, and then Modbus, you have your Modbus registers list. So those are just a few of the tools without going way into the weeds on any of those protocols. All right, and then you have other systems. All right, so here in a nutshell is one way to think about that chilled water VA system that we had on the previous page. All right, so remote access, right? I don't want to go into the office. I got a snow day up in Flagstaff, and I want to shut down the building because I don't want it to go occupied. We have minimal crew. I don't want to burn that energy, right? Utility interactions, demand response, real-time pricing, right? We need to be able to respond in a way that we have, one, we need to negotiate with the utility provider, right? What is our agreement with them? What are our charges, right? How do we prevent peak charges? So going back to that chiller plant, if we start up in the morning, let's say we have 5 chillers, and our load eventually, say, within an hour of occupancy, we need 4 of those chillers. Do we slam them all on at 7 a.m.? Anybody? Why wouldn't we? Yeah, the peak just shot, and we're tied into that peak charge for how long? Months, right? So some of those things. Or it could be as simple as bringing on your rooftop units if it's a rooftop VAV system. You don't want to slam all of those on either, right? Stagger them as appropriate. So some of the things, unintended consequences. It sounded good until we were locked into that rate for 6 months, right? And then other operations, business, cloud integrations. How often are we able to have a shared, I'll say land, right, versus dedicated land, one to the BAS and one to the rest of the network? What is the preference in the Phoenix area? Independent?
Standalone.
Okay. More from a cybersecurity perspective?
No, from usage.
Perfect.
Also fire, separate too.
Yes.
Anybody interfering with that, it may give you the ability to monitor an alarm or something, a condition that has occurred. You don't want to take on the responsibility of doing anything with that.
Engineered smoke control, right? Yeah, agreed. So that's one that's waffled, that's gone back and forth over the years, right? Not the fire, by the way, not the fire and the smoke, but I'm talking about the business, land, and the building. Because we, again, working with the military bases, they would glue, back when USB ports started being integrated, they would glue those suckers shut so no one could stick their thumb drive in there, right? So they did not, they wanted dedicated land to the building automation system. And frankly, security by obscurity is one of the phrases with some of these automation systems. There are times we hack into these, right? Depending on the legacy. If you get down to that MSTP layer, you can hack in. So things to think about, right? All right, so let's take a look here. On this side, let's keep playing. Here we go. So we're just going to take a look at on the VAV side, but there are a number of other systems that might be in your building. And I had fun there. Northeastern Indiana, Allen County Public Library, and where I started my career was at that particular sales office, but I had the opportunity to turn around and work with them with this project. They had 13 different systems, and these are just a few of the systems, but what do you do if the glass breaks, right? So it's after hours, and we detect that a window was broken at our library. And why do they care in Fort Wayne, Indiana? Because at the time, they were number 3 in genealogy behind Salt Lake City. So they had a lot of extremely sensitive records, and they have 3 massive rivers that come through the town, and the floodplain was so close that if they didn't keep those sumps pumping that water out, it would flood. So they had a lot of very critical operations with that library facility. So it was the main library and a number of branch libraries. But one of the use case scenarios was, okay, I detect glass breakage. What am I going to do? It's 2 a.m. I'm going to turn on the lights. I've got the CCTV cameras, right? I'm going to pan, tilt, zoom, get over there, see if I can see what's going on. Oh, by the way, I'm also going to generate an alarm. But what are the things that you can do if you have communicating information? And again, going back to that single seat of operation, not all of this, like CCTV, I've not done a deep research recently to see if we have backlit CCTVs, but that was IP. So on the building automation floor plan and graphic, we were able to have IP links to those cameras, so then you could go in and you could do the whole pan, tilt, zoom, and all that stuff right from that graphic. Even though the data wasn't integrated when I was looking at it, you could still have access to that. And the CMMS, the computerized maintenance management system, we have some that talk PACnet and other protocols that we can share information that allow us to generate alarm. Oh, by the way, here's a work order that goes along with that. All right. So again, some of the examples, we're just talking about that. And I think we've already covered all of this just with our conversations. What happens, right, when I come occupied? If it's a conference room, right, if I've got my conference room, I might go occupied and be ready for them, but I might go into occupied standby mode. So I increase my volume of outdoor air, but not so much, because I don't have people in there yet until the occupancy sensor. Maybe I'm integrated with Microsoft Outlook or something like that. That's when I bring in the additional outdoor air based on my CO2 sensor feedback and actually 62.1 and 90.1. And then what happens when the room is vacant. So these are just real simple, straightforward examples of why you might want these systems to work together. And so when you're looking at your facility, and I'll see if I can wrap this up in about 5 minutes so you can get on with your day here, is when you're looking at your customer's facility, since we don't have any building owner operators in here, is what issues or complaints may exist, right? And I've got a list of them on there, things to think about. Going back to that one facility where we have, right, someone came up with stuffy, unusual sounds, that squealing, right, when you go into some of those warehouse stores, you can hear, you've got a belt issue there, right? That's an issue, right? Easy to set and forget. Who's minding the facility? So again, if you're relying on the human, how much experience does the typical human have? Or how much time, even if they have the experience, do they have the time to go in and manually look at everything? Or can we use that automation system to assist us with this? Right? Again, how well trained and qualified are they? Falls into that. And so here's just a few things from an energy efficiency perspective. Just a quick overview. I think most everyone here has heard of some of these, right? Occupancy-based control, absolutely. Daylight harvesting. We have the beautiful sun over here. We don't want too much of a solar load, but when it's not pouring in, it's nice to have that natural sunlight in there. Integrated scheduling, getting everything to work together. Zoning and load shedding. What can I shed? How long might I be able to shed it? Do I bring it on early because it's going to be a peak cooling day? I'm going to start a little earlier so I can subcool just a little bit, so then I can drift just a little bit, right? And still have everything comfortable. From a safety perspective, right? Emergency lighting and HVAC integration. There may be my egress path, and if I can control those lights, maybe I've got addressable ballast, whatever that happens to be. How do I light things up in that smoke control? So again, going back to monitoring, if I've gone into that smoke control mode with fire smoke, maybe I do something with my lights to help people find their way out, right, safely. All right. We talked about the motion detection and surveillance. Here's just a few more things. That whole personalized zones, I'm waiting for that to really start taking off, right? Where you even, I was out working with some people from NIST, the National Institute of Standards and Technologies, and we're at the University of Virginia and putting in the living laboratory there. And that was one of the things that they were doing at that campus, is they wanted to, everyone had their smartphones, right? So I like my room at 72, you like yours at 68, you like 74, whatever that happens to be, vote it. right? What is the classroom? Oh, by the way, the professor gets 5 votes, or whatever that is. But that personalized control, that is something you can do. I'd love to see us be able to do that, right? Feedback loops and after lighting and temperature. And at this point, I'm going to stop, because these are a few of the items. I've got some screenshots as far as what's on the EPA Energy Star. They've got a really cool tool if you're ever working with a customer, if you've not seen these, and they're looking for something that they can do on their own. There's a treasure hunt guide where it will walk them through. What do I do for HVAC? What do I do for lighting? What do I do for this? And it gives them very practical suggestions on what they may be able to do on their own. And with that, thank you so much, everyone.